It's 4 o'clock. Thank you for you guys be making hopefully had a great day here in TrailheadX. My name is Yari Salama. I'm one of the product managers for Salesforce Platform. I run a team called Platform Data Services, and I'm here joined by Mike. You want to introduce yourself?
Yeah, thanks, Yari. Can you all hear me okay? I think I'm on. Well, hey, thanks for being here this afternoon and for joining us here at Trailhead DX. My name is Mike Salem, and I'm a solution engineer here at Salesforce, and I spend most of my days working with various customers all over the US and Canada on different kinds of data architecture use cases and solutions and challenges, and just kind of how to think through, you know, what does data architecture mean and how does Salesforce approach it. So thanks again for being here.
Thanks, Mike, for being here. So today's topic is strategies for big data. Before we kind of jump in, let me give you the forward-looking statement as a product manager, and you know, we might touch in some topics that are currently in pilots. There might be a beta, you know, they're forward-looking. So if you're making any purchase decisions of anything that we covered in this talk, please make those by readily available features. That being said, let me kind of give you this, you know, start up by giving some context. So, you know, you've heard a lot of talk about how customers want to be connected to the services. You know, we talk about these digital experiences that we want to deliver. You know, welcome, please come on in. There's a little bit actually seats here in the front if you want to, you don't have to stand in the back. So these really intelligent services, and what's really behind these services, of course, is data, right? So the more data we have, the more richer experiences we can gather, the more order history we have, the better we can forecast hopefully the next order, right? So to really deliver these digital experiences and provide this kind of intelligent view to the customer, we have the customer success platform. So we have a variety of different products. They're really all powered by the Salesforce platform. And obviously inside the platform, we have a bunch of shared services, and there's a lot of capabilities that you as a developer, administrator, architect don't have to individually architect and develop every time you have a application development project, and you know, whether it's being like you know, profiles, roles, access patterns, UI, search, and so forth. So now that we really think about this in the data context, and we want to build, like Mike meets a lot with customers every week and travels around the country. Why do you think companies should really have a data strategy or think about this as they're building their platform strategies and Customer 360 and other things?
So one of the biggest themes that I see coming up with the various, you know, types of customers that I work with, and I work with, you know, customers that can be startup size all the way to Fortune, you know, 50 enterprise level. And a trend that I've kind of been seeing more often than not is that a lot of customers today, whether they're working with Salesforce or, you know, other types of technology, are a little bit in a reactive mode when it comes to data volumes. And what typically starts to crop up is that different data challenges, you know, are these kind of isolated issues, these isolated projects, isolated teams. And they aren't always thought of as, you know, how can we get a handle on this holistically? How can we be proactive in what we mean and what we think about when we think about data as a value driver for our platform? And really looking at data as something that can be looked at as increasing business value. You know, a lot of my customers, will start the conversation off with, we have to meet some sort of compliance requirement, or we have to meet some sort of regulatory requirement. We have to keep this thing for 7 years or whatever. You know, we might have to query it, but, you know, we don't need to see it in the UI, or reporting can be, you know, in batch or real time or whatever else. And a lot of the conversations will start with just kind of solving what seems to them like this anchor. And we can solve it. Like that's, you know, that's not necessarily the big challenge. The challenge is getting them to understand how they can then use this information to actually make decisions for their business, how to transform that into being a proactive source for insights and, you know, hopefully revenue or time savings or anything else, as well as being able to check some of those boxes behind the scenes. So moving from proactive to reactive.
Right. So let's discuss about the different approaches to this. So obviously we have a Salesforce platform that provides very rich set of functionality, and I guess many of you in the audience, you fulfill different requirements, whether they come from an IT business, you know, to work on different projects, right? So Could you, Mike, elaborate as you work with a number of developers and different customers about the differences, whether you're working on a data project or a single project versus a platform approach to these problems, and what really drives that?
Yeah, so we get into these conversations around how do you think about data as a platform-wide or an enterprise-wide strategy versus how is it sometimes kind of looked at as these individual isolated projects that need to be solved for, again, among different teams or different departments or whatever else. And the first thing is how can we find synergies among all these kinds of things? Like if we find a way to manage hundreds of billions of records, or if we find an archiving process that works, or some way to feed this data into the UI or use for a machine learning model, how can we start to reuse that? How can we take advantage of the experience and the skill sets and the technologies that we use in one area to start to reuse it and allow other areas of the business to move that much faster as well? And so one situation that I ran into recently was with a customer who had set up email to case. And so as their business grew, their volume of emails grew right alongside with it. And kind of before they knew it, they were creating more cases than they had anticipated at first. And so a few different areas started to come into play. Do we have enough storage capacity? Is our performance staying at a reasonable level regardless of volume? Do we want to delete these cases? Can we delete these cases? Or what other kinds of value can we find from that? And so a couple of those bullets that I just laid out actually were the responsibility of a few different teams that I worked with. And so if you look at a slide like I have here up on the screen, there's so many different types of data that are coming in, and the volumes between that data ranges. So the email to case example, we're seeing cloud data, we're seeing SaaS data, human-generated data growing on its own. But when we think about all the different kinds of information that's coming in as well, it's just exploding. And so in this particular example, we had a way where we could leverage those cases coming in through email into some of our machine learning models. But the conversations I was having was in two different teams, actually three different teams. One was the service team that cared about how they could respond to those cases. Another was, an infrastructure team that cared about the storage and how to go about that adequately. And another was a data science team. They wanted to know where they were going to get the data for these types of models that they wanted to run, to then turn around and actually adequately help that service team that I mentioned at the beginning. And if we're not coordinating these kinds of efforts, this could have easily been 3 different vendors. It could have been 2 cloud, 1 on-prem. It could have been just kind of a hodgepodge of things that get put together, going back to that reactive mode that I mentioned earlier. And where the conversation went was, how do we set up a foundation to handle these challenges, reusing skill sets, leveraging things that we've already built while still satisfying all the needs of these different parts of the business.
Yeah, that's a great insight. Like there's a different, obviously, different insights, different technology stacks. And when we put this in the Salesforce context, there's also different kind of ways to manage your data in Salesforce, right? So we have custom objects, we have integrations, we have external objects, and now we have custom big objects. So could you kind of highlight to the audience some of the key differences between like the SQL and NoSQL and what those really stand for in the context of our current object model?
Yeah, so quick show of hands, who here is familiar with custom big objects? So for anyone who watches this recording later, about a quarter of the room, which is to be expected. We're going to get into custom big objects and how they work, but typically when we start with these conversations, whether it's internal, whether we're doing kind of enablement with partners or in the developer community, or when I'm talking with customers about how to solve their specific challenges, more often than not, the first question I get has to do with like, what's the silver bullet? 100% of the time, if this, then what should I do next? And the reality is when we get into these types of large data volume challenges, big data challenges, there's not necessarily ever going to be just a one right answer that's always going to be the right answer. It's all based on the use case that you have, things like disposition of the data, how do you need to use it, how do you need to store it, so the specific use case itself, as well as the volume. I mean, how we interact with 1,000 records is going to be very, very different from how we interact with 1 billion records, and there's trade-offs on each side. So what comes up a lot at Salesforce is, like a slide like this one kind of alludes to, is how do we think about external objects versus standard and custom objects, and now that we have custom big objects, where do we find that delineating line, and when do we use what for these different types of use cases? And so another thing to keep in mind is, what's the skill set within the organization that you're working within? We're at a Salesforce conference. Are they Apex developers? Are they Salesforce admins? Do they want to stay within the Salesforce ecosystem, going back to leveraging those skill sets and investments that they already have? Or are they using other types of technologies? Are they Java developers? Are they Ruby? Something else? And maybe they've already built an application. Maybe they already have data stored somewhere else, but they still need to use it within Salesforce as well. Again, another thing to consider is, virtualizing versus persistence. So in the second example I gave about, other kind of stacks and other kind of storage that maybe aren't in Salesforce itself, that's where external objects start to come into play. That's how we can expose that data within Salesforce, whether programmatically or through something like Salesforce Connect. But when you talk about these kinds of issues, you also have to get into the volume, and when I mentioned disposition, how you're going to use it. So for Salesforce Connect, for example, there's certain limits, right, to virtualize it. You're reading the data, you're not storing it in Salesforce. And so if you're working with a small set of data at any given time, you just need to view a few records, that can be a great approach. But if you're in a position where you have, many, many millions of records or more, especially when you're getting into the hundreds of millions or billions, and you're trying to query it, you need to store it, you want to do some really complex type of computation on it, an approach like external objects in Salesforce Connect isn't always going to get you there because of, certain types of integration limits that exist. When we get into storing the data in Salesforce, when we think of standard and custom objects and persisting it, and the value that can also come with persisting data in Salesforce, when we think about Apex and SOQL and additional types of custom app dev that we can do on the platform, we're generally safe within the 1 to 20 million mark in terms of relational database and performance and volume and how that kind of all works, and we'll get into that here in a little bit as well. When I see customers that are using standard and custom objects and they're approaching that 20 million mark or they've just shot past it, I tend to start to ask about their velocity. Are they going to get into 100 million? Are they going to get into a billion records or more? And then we start to have a conversation about what is the disposition of that data. Are they still actively working it day in and day out? Like if there's a billion cases out there, are they actively working? Are those a billion open cases where data needs to change every day and update? Or is it data that's more static? Is it historical data? Or is it things that have happened in the past but aren't necessarily going to change anymore? Or is it time-stamped or machine-logged data that they need a place to store and persist to then find value in later? And in those volumes and those kinds of dispositions, that's typically where we start to bring up custom big objects and the NoSQL kind of underpinnings that are there as well.
So would you say, to kind of recap that, that we kind of see in the custom space that a lot of the use case comes to the data versus then that the use cases go where the data is? Like how does that work?
Yeah. So when we get into these kinds of volumes, we have to think about, are we shipping the data around to all these different places? And when we think about integration, what does that mean for both limits and also time that it's going to take to compute and interact with all that information? And the reason that we have this option with custom big objects, and we'll get into the infrastructure, how it's built, and why that's important. But bare minimum, the reason why we have it is because in this big data world with the kinds of volumes that we're interacting with today, it makes so much more sense to bring the computation to the data. So storing the data in a place like Big Objects and being able to run your SOQL queries, being able to do your batch jobs, and being able to use it in all the other types of Salesforce features. Because you're just not going to have a performance solution, whether it's through the performance of the system itself, regardless of what technology you're using, or any kind of limits that you're hitting, if you're constantly worrying about, how do I virtualize or ship this data around in a persistent manner at those volumes.
So there might be already like, customers here, developers, architects, people here in the audience that have massive data volumes in their current custom objects or in their SQL objects. Is there any thoughts about what really drives this, their next step? And then how do we really define big data in terms of these different use cases as you talk with customers? Do you want to give that extra color?
Yeah. So when we think about custom big objects and current customers that are using standard and custom objects that have now grown in great size. In the past, we kind of talked about storing data in the cloud, and we abstracted everything else behind the scenes, and you don't have to worry about it, et cetera. But when we think about the amount of data that's being created today, it really is an information explosion. Like we mentioned with things like the email to case, right? Human-generated data, IoT and sensors and how all that works with things like our flows and everything else. And so what we really have to start to think about is what's the best use for a specific database technology at any given time. And it's somewhat of a new conversation for Salesforce as a company, because we only had one database option up until now with Custom Big Objects. And so when we start to get into SQL versus NoSQL and how that relates to relational databases versus NoSQL databases, that's really where we can start to get into conversations like information lifecycle. Are you using the correct database at the correct time for the current need and use and scale of the data? Or are you evolving it through the life cycle of how that data should be managed and what that means for different database technologies behind the scenes? So typically when we talk about these types of options that we have, I'll get asked, well, what's the definition of big data? What's the definition of large data volumes? How do I know if I should be using standard or custom objects, or if I should be thinking about moving it over to somewhere else like Custom Big Objects and more of a NoSQL approach? And when I've worked with customers, the common thread that I've seen is that big data could pretty well be defined with these 3 V's that you see up there at the top. The first is the volume, and we've talked about this a lot already. So are you working with a few gigs? Are you working with a few million? Or are you working with petabytes? And are you working with a few 100 billion records or more? So volume is going to be the first key. That's why it's big in the big data definition. But the other 2 are also going to be volume and variety. So a really, really important thing to consider as we architect solutions that are going to be future-proof is how fast is that data being created. So when we talk about data velocity, it's going to get into, are you creating 1,000 records in a year, or are you creating 1,000 records in a day? And what's that going to mean 6 months from now based on the database option that you've chosen in terms of performance, queryability, and how your users are going to be able to interact with that in the UI? So when we think about architecting and designing for a big data application in this type of big data world, data velocity is going to be key to be able to understand. And a lot of my customers, sometimes they don't always know what their data velocity is. I mean, if I can walk into a meeting and they can tell me, flat out, hey, we're creating 1 million tasks a day, and we got to figure out what to do with that. That's a much more efficient conversation than, going back and running reports and kind of talking to different teams and figuring out how much this data is being created. It's fine if it happens, like it's an exercise that everybody eventually is going to go through, but it goes back to being proactive, right? Getting a handle on what those measurements are. And then also the variety. So when we think about the variety of data, especially in a Salesforce context, we have, all of our different cloud applications. We have our platform with all the custom applications that our customers build. And then we also have a lot of features of Salesforce that generate its own data. So in my email to case example, that would be the data coming in from Service Cloud and what that kind of data looks like. On the platform side, we might have a custom application that's HR related or payroll related. Or maybe even IoT related, right? Some of our customers can wire up all kinds of things to their Salesforce instances, and they're bringing those logs in with things like high volume platform events or others, and we need to track that data and manage it. And then also, I'm sure you've all heard of all the different types of Einstein features that we have. When we talk about Einstein and machine learning and deep learning and linear regression and neural nets and convolutional and recurrent and all this kind of stuff, we think a lot about how much data is needed to help train those models, but what we don't always think through is how those types of features, regardless of Salesforce or anywhere else, how those types of AI technologies also create a lot of data in and of itself. So if I wanted to use something like Einstein language to automatically analyze the cases that were coming in through email, Einstein language is going to give one-to-many categories. It's going to label a case as product A or for this region or for this marketing campaign or whatever, and it's now creating data on its own. So that's where variety starts to come into play. Is it actively being worked? Is it machine generated? And how we have to kind of manage that. And by being able to get a handle on all these, I would say, velocity is probably the one that a lot of my customers are least maybe used to analyzing. But by getting a handle of all these three, that's kind of where we start to get the value out of all this as well.
Do you think you also have the value there that do you think more is good, like the more you have is better? Like, is there some kind of a, it's 2019, I think most people don't really delete data, like, using Facebook, Twitter, Gmail, different, like you just constantly accumulate more. Is that a never-ending thing? And do you think that's good for customers?
I would say, so I would like to always say that more data is better in general, but it's not always the case. And when we think about, especially when we're scaling into like the billions of records or more, it starts to become much more challenging to query across it efficiently and kind of make sense of what it is that we're looking at. And while, NoSQL as a technology domain has made such huge strides, we still have to have ways to provide database level controls to what we're looking at. One of the things we'll talk about here in a little bit is different types of NoSQL approaches and the technology that can support it, Hadoop being one. And one of the things I see sometimes with customers who are using some of these technologies is that they'll use a limitless bucket, like a NoSQL kind of document storage, but they haven't also put all the controls in place to allow an admin or an end user or somebody to query it in an easy and efficient and real-time way. And so what they've done is they've taken all of this data that they have that's very, very valuable, and they've relegated it to, kind of a behind-the-scenes, very programmatic-centric batch operation that doesn't really allow itself to have the business get answers to their questions in a very meaningful way. So yes, more data, ideally leads to more value, but it's also how you've managed it, how you've structured it, how you can query it, and what kind of controls you've put around it that really is the answer to more data equaling more value.
Got it. So time to live and the overall aspects are important. Now, a lot of these kinds of questions have been around for a long time. So is this really a kind of new problem, or is it a new solution, and why is it relevant now?
Yeah, I wouldn't say that the issue of managing data is a new problem by any stretch, but there's just different ways to handle it now, especially within the Salesforce ecosystem. And if we think about how it used to kind of work, if you had a massive amount of information and you had to figure out a way to manage it and process it and query it, you might go ask whoever, your boss or somebody, for a huge check, and you'd buy the biggest box you could buy. And then you'd go and try to get another check, and you'd buy the most powerful database you could afford. And then you'd probably get a team of developers to build some sort of application that would allow you to ask questions of that data set that you had, and get answers, in some sort of time-based format. And while that used to be the way that it would work, that's no longer the case anymore when we talk about scale, and how we can provide, controlled NoSQL options for our customers.
Okay, so we have a very technical audience here in the developer conference. So let's deep dive. We talked a lot about the SQL and NoSQL. Let's can you, Mike, put this in the context of Salesforce? What does it really mean?
Yeah. So to start out, when we think about NoSQL versus NoSQL, a lot of it goes back to the word that I've used a few times, the disposition of the data. So a SQL database, which if you don't already know, is the underpinnings for standard and custom objects. They're a relational database behind the scenes. They're a SQL type database behind the scenes, and so they have all the pros and cons that come with a SQL database. And so SQL databases are really, really good for very complex relationships, updating, editing, upserts, all that kind of stuff day in and day out, and they're really, really fast and really, really performant for those kinds of things. All the things that we would think of when we work with standard and custom objects today, right? All the junctions and many-to-many, working with business processes and triggers and workflow and all this kind of logic, and how we use that to just help the business run. And that's why they've been so great, under the hood for the Salesforce platform for so long, because they're the primary driver for day-to-day work for business. But in general, regardless of if we're talking standard and custom objects or some other type of technology, In general, where SQL systems start to run into issues is when the volume of data stored in those systems goes up. If the volume grows to a great enough size, the performance of those systems can go down if we don't also incorporate a lot of technical overhead. In the Salesforce ecosystem, this technical overhead can take the shape of skinny tables. If you're trying to get your data out, it can take the shape of PK chunking. If you're working with a non-Salesforce SQL system, it can take the shape of database sharding. And there's just all this additional maintenance and additional overhead that goes into keeping SQL systems performant if the volumes are growing in a very, very massive way. And so where NoSQL starts to come into play is if you need the system to stay performant regardless of the volume, but it also has to be the right kind of data. And that's why I've made a big deal about talking about information that's changing and being used day in and day out. So I typically talk about cases a lot because a lot of the Service Cloud customers that I work with, went out for a second. A lot of the Service Cloud customers that I work with tend to see huge spikes in their volume based on the different types of service issues that they have to solve. So if I had a customer who has a lot of open cases and there's different kind of case teams and they're updating the fields and things are changing and they're transitioning ownership and all that kind of stuff, that's probably not going to be a good candidate for this NoSQL type of approach or in Salesforce vernacular or custom big object, because we need all those day-to-day real-time updates to be happening and all those relationships to kind of be spiraling out for that business process and workflow to continue. But once that case is closed, it may reopen. More likely than not, it probably won't. But so many of my customers just keep those cases on the relational data store that they've used for a variety of different reasons. And that's where we can start to get into the disposition of what makes sense for NoSQL. If you have 100 million closed cases and you're not doing a whole lot with them in terms of day in and day out business process and manual data entry and all that kind of stuff, but you want to keep them either because you're regulatory or legally required to, or you want to use them in your machine learning models, you want to be able to report on them and do that analytics down the road. If you keep that in a relational data store, you're using up a lot of that precious storage that's generally geared towards data that should be actively being worked day in and day out. But if you start to move that information over to a NoSQL store and Salesforce vernacular custom big objects, now you're starting to think through, am I using the right database at the right time for the kind of data that's coming up?
Got it. That's a great insight. So there's also, it sounded to recap like there's a cost and performance implication of this. So if we keep data in transactional stores, obviously we're not using the transactionality, we're kind of like wasting certain resources, as well as then we are unable to store the immutable data in a transactional store. So great insights. Thanks, Mike. Okay. So let's deep dive into these use cases in a little more detail. You talk with a lot of customers. So what are really like the drivers for big data specifically? So what kind of custom big objects are customers creating? Would love to hear also from your room, if we have time for questions. But what are you seeing? What are the driving use cases for custom big objects?
Yeah. When we talk about just data architecture and data management and this world of big data, the use cases can vary wildly. But typically, I've seen them start to fall into these three buckets. And even the use cases within these three buckets can still vary. But what a lot of customers have been coming to me about is the notion of information lifecycle management on the Lightning platform. And at Salesforce, we talk about application lifecycle management with things like Salesforce DX and sandboxes. We talk about service delivery and all the kind of security kind of things that are involved in Shield and all that kind of stuff. But somewhat of a new conversation, and now because we have a second database option, is the notion of information lifecycle management. How is the data moving through my system in a way that makes sense, both for cost reasons, for performance reasons, and making sure that I'm working as efficiently as possible. And so information lifecycle management can take a number of different forms. It can be heavily geared towards the security side and being able to identify the right kinds of data that should be PII, that should be PHI, more kind of a data governance strategy and what do we retain for how long and why. It can also take the form of archiving and what that means for a broader, enterprise-wide archive strategy. And this goes back to that case example that I used earlier. Are we archiving these cases that we're no longer working, and not just kind of cluttering up the relational database that's actually better served for other purposes? And the archiving use case within information lifecycle management starts to speak to how can we use the skill sets and investments that we already have to provide efficiencies for the rest of the application. So if you look at how we have, ILM, the information lifecycle management, moving into Lightning applications, this is how we can take the notion of archive from, the basement or the closet or, wherever. Typically when customers talking about archive, they think of things that are like cold storage that they just don't want to use anymore. But we can actually find a lot of value with our archived data by using it in our UI, in our Lightning application, and giving our end users, so like a Service Cloud agent, for example, real-time access to that archived data. So the second thing is, how do we use these large data volumes, these billions of records or hundreds of millions of records or more, in our UI, in our Salesforce applications, just like we do anything else? And what kind of forms does that take? And so we'll show you a demo here in a little bit about what that could mean. And then the last piece that I see come up all the time is machine learning. And we kind of touched on it a little bit already. But if you think about things like prediction builder, Einstein discovery, all the data that's needed for the different embedded Einstein pieces in our different clouds, all that stuff is churning through either on Salesforce or off Salesforce data. And in this case, the more volume you have there, the more confident your models are going to be, the more accurate their predictions are going to perform. And this is a prime area to think about NoSQL systems, custom big objects being one, as a repository for these types of models. Let's think about, if you want to use prediction builder and you want to use it in a sales context, and you want to have predictions run on opportunities or accounts for, propensity to buy, maybe propensity to churn, things like that. Typically, how you would do that is that you would feed a model like that with historical opportunities, so things that aren't being worked anymore. But if you have, if you're doing great and you have hundreds of millions of closed opportunities, then more power to you. But why would you be keeping those hundreds of millions of closed opportunities on your relational data store that's clogging down that real-time transactional system? You can start to move that kind of stuff to a NoSQL system in Salesforce on custom big objects and still use it for all your ML models down the road. So we also start to talk through, if you look at a slide like this one, Salesforce kind of stack. And if you look at what I've highlighted in red, if you saw a Salesforce stack like this, even last year, you probably wouldn't see in the data column that there's two databases. And that's because we just didn't have this option before. And so if you look on the left-hand side where it says relational DB, that's where we think about our standard and our custom objects. And on the right-hand side where it says big data services, that's where we start to get into NoSQL. That's where we start to get into custom big objects. But the reason why they're such a big deal, and in a lot of cases often not well understood, is because the primary differentiator for why custom big objects are so valuable to Salesforce implementations is actually what's going on behind the hood. So Salesforce Big Objects, or Custom Big Objects, is actually built on a stack of 3 big data technologies. One that we actually invented here at Salesforce, and now it's very widespread. We use a combination of Hadoop, HBase, and Apache Phoenix. And there's 3 very specific reasons why we use these things as one cohesive solution. And then we've wired it into the Lightning platform so that it's native. It's not an integration-based solution. You're still using Apex, you're still using SOCL, and everything is very, very tightly built into the platform. So what that means for admins or developers is that they're getting the benefits of these 3 things, and we'll go into detail about those later, without having to be experts in those 3 things as well. And so that's a really, really big deal when we think about very, very large data volumes.
So Mike, we got 5 more minutes left, so let's try to recap this, and then obviously it wouldn't be a developer conference without actually showing this technology. So we talked about Hadoop and HBase and Phoenix. So without kind of like going into deep, maybe in a 1 minute, like how would you describe the audience working on the Hadoop and HBase and Phoenix stack on Salesforce than compared to maybe building their own big data architectures and systems? And what are the kind of like the caveats or the trade-offs?
Yeah, so when we think about those three things combined, there's very specific reasons why we've done it. Hadoop on its own is arguably, one of the most groundbreaking data management breakthroughs that we have in our time, and that's because of the notion of parallelism. So when you're working with Hadoop, you're working in clusters, and what that typically means is that you have lots of computers or lots of systems working together to provide you that added storage and added processing capabilities. And why that's different is because in the past, you had, one machine, and the word is escaping me, but you enhanced it vertically, meaning in that one box, you bought better and better versions of the type of technology that could fit into that box. But sooner or later, you'd hit a limit. The box can only hold so many server racks. You can only buy, so many of the best database technology within that box. And so with Hadoop, with clustering, we can now scale that horizontally. And if you want more power, if you want more storage, you just add another box to it. And so that's something that we're doing at Salesforce behind the scenes. Where Hadoop falls down is that it's not a database. So there's specific things that a lot of our customers expect out of a database. They need certain types of structure, certain types of organizations, relationships, lookup fields, validation rules, all these kind of things where we have to know the format of the data being stored so that we can act on it in certain ways. And that's where HBase comes in. So HBase is actually a distributed database that sits on top of Hadoop. So Hadoop gives you the limitless storage and processing capabilities through that horizontal scaling. HBase gives you the ability to work with that like a database. The third thing is Phoenix. So Phoenix is something we actually invented here at Salesforce. It's been accepted into the Apache Foundation and is now used all over the world. And the reason why Phoenix is such a crucial part of this stack is that it gives you SQL-like querying capability. So if you wanted to go build your own Hadoop stack, if you wanted to go do HBase on your own, you'd have to be, Java developers with heavy Java experience and also, a lot of knowledge on how HBase works. You'd be writing direct HBase database operations in Java every time you wanted to do anything when you queried your data. And so Phoenix gives you the ability to write SQL commands that then get translated into all of the kinds of operations that HBase can leverage going into Hadoop to retrieve all that information. So those three things combined give Salesforce a way to allow admins and developers to run things like SQL queries. The SQL query gets translated into the SQL Phoenix layer. Phoenix translates it into HBase, and HBase runs all the queries. And so what that means for our Salesforce ecosystem is that you get all the benefits of some of the most groundbreaking big data technology that we have today, while still staying within a Salesforce mindset. And that's what I mean about leveraging current skill sets and technologies, Apex and SQL, but still getting the benefits of Hadoop and HBase.
So could you, Mike, show that in action, like how to do a real-time query over a data set that is bigger than 1 billion rows, and what's the performance of and this magic behind Hadoop, HBase, and Phoenix really look like in real life?
Yeah, so I stood up. You hear me okay still? All right, so typically a question I get asked is, especially for people who have worked with Hadoop in some case in the past, is when we think about big data, Hadoop being one of the approaches, typically it involves batch access. So you're querying 1 billion records, you go get a cup of coffee or kind of turn out for the night. You come back at some point later and you have your answer. But because all of this technology is wired in through the Lightning platform and we're using things like SQL, which is real time, we can still process these types of queries in a very performant and real-time way, even though we're using these big data stacks behind the scenes. So the example that I have up on the screen here is a Service Cloud instance. And the idea here is that I'm a Service Cloud agent. Somebody has called in. The company that I work for happens to rent, bikes and scooters and all that kind of stuff. And the person calling in has a question about, some of their rental charges. Maybe they weren't showing up right, or maybe they got double charged, or maybe they're just trying to figure out, if they owe anything else on their rental. And so if you think about that kind of information, rental level data, order history, that kind of stuff, most, if not all of that information is not going to change. It gets inserted, we keep track of it, we look it up if we need to, but it's not like you have your Service Cloud agent necessarily going in there and changing the order history. If they need to update something, they can insert a new row, but we have to keep that audit level information to be able to run the business effectively. So this related list right here,
Yeah, I was just asking, thinking about like, so as we're looking at the related list and how quickly it loads, so this is Lauren's write history over how much data we have that we're looking at in this list?
yeah, so this one table, this related list, which is a custom big object behind the scenes, has 2.6 billion rows in it. But because of what we're able to do with the Lightning platform and how we're using that stack that I mentioned, whenever the Service Cloud agent brings up this related list, we can dive right into those 2.6 billion records and pull out the information that's specific to Lauren Bailey at a moment's notice. So when we talk about Lightning applications, this is how we can still leverage big data technology for the back-end performance and cost benefits that we have, while still adding value to our end users, our front office people that are dealing with customers.
How about reports and dashboards? I'm sure reporting and analytics comes up all the time.
Yeah. So another issue is, if I'm not just an end user and I don't need to see, a small subset of the information, what if I'm an admin, business analyst of some kind, and I want to report on all this kind of stuff? And so you can still do all that while using standard reports and dashboards in Salesforce, using custom big objects. The information that you're seeing here on this dashboard are different reporting snapshots, you can call them, taking different kind of slices and dices from the custom big object table behind the scenes. So we've done a few different things here. We've done a couple different counts. We've done some group buys for aggregates. And what we've done is we've gone into the custom big object, again, with those 2.6 billion records, and we're seeing things like the top bike rental locations, the top drop-off locations, the top 5 most recent bikers, and also the current bike rental routes. So what you can start to do here when I talk about business value and insights and being able to take action is we're not only storing the 2.6 billion records for posterity, but we're now able to analyze it in a really meaningful way. So maybe this company, wants to run certain campaigns at these locations because they identified that those are the top ones. Or maybe we want to give, some sort of program to the top 5 recent renters because, they're the ones that are showing up in our report. So you can still use this information in a very Salesforce familiar way, even though you're taking advantage of a completely different and very, very powerful data stack behind the scenes.
Awesome. So we have, as a summary, a few more slides. We have a little bit of breakfast tomorrow, if we can go back to the slides.
Yeah.
So tomorrow morning, if you're around and you want to meet the team, so we're hosting a little meet the team, meet the product team and discuss your big object projects. You can go to the bigobject.info. There's a sign up for a breakfast. We are meeting at the Salesforce West Tower, a few blocks from here. So if you want to come ask technical questions, about your implementation, please sign up through there. Really my pleasure to have you here, Mike. Thank you for an awesome overview. And we're going to be outside the conference room to take any questions if you have. I think unfortunately we don't have probably time for questions, but we will take them outside the podium. So thank you for attending.
Thank you all.